But what I want to talk about to you today is why do we do this, okay? I kind of did my degree in physics and applied math, and then I did really hardcore maths, and now I'm doing more observational things. But why do we do this? Because we want to explore the universe. We want to learn. There's so many things out there that we want to understand and put together and improve our own knowledge. And the SKA, which is this massive telescope that's going to be built in the Karoo, is going to help us to do some of those things. Okay, so when we look at the sky, what can we see? We can see stars, like you see them roughly here. You can see comets, you can see planets, rocks, and we can see these things. But we can see more things. We can see galaxies. So that blob, it's a galaxy, and a galaxy is a collection of gas plus stars. So if you think now in size, we live in the solar system, and the solar system lives inside the galaxy, and there's loads, millions and millions and millions and millions of solar systems inside the galaxy, and that's just one galaxy, okay? And there's all these things called AGN, which is, hopefully you can see, which is a galaxy that has a very, very strong engine in the center and produces a lot of energy, and we can also see that with SKA. And then we also have millions and millions and millions of galaxies and millions of galaxies that we can see in the same place in the sky. So we all want to see all these individual objects. But if you think that when light from the sun gets out of the sun and comes to us, it takes 8 minutes to reach us. So a photon, piece of light, leaves the sun. It takes 8 minutes to reach us, and then 8 minutes after we see it. The nearest star, which is Proxima Centauri, when they emit light, it takes 4 years to reach us. And the nearest galaxy, which is a satellite galaxy of the Milky Way, our own galaxy, which is Canis Major, dwarf, it takes 25,000 years to reach us. So, if we want to look further away, we actually, what we do is we actually looking back in time. So when we see something that comes from very far away, we actually see in the past. So when we look at the furthest things in the universe, we're looking at the oldest things that exist. Oh, unfortunately, you can't see very well this picture, and here you have the history of the universe. Ooh, now I can see better. The universe must have begun here somewhere. And then a period called inflation happened, and the universe grew, and the first particles were formed, and something that we call the cosmic microwave background was formed, and this is when the hydrogen was formed. So hydrogen became hydrogen, so protons and electrons bound together to be hydrogen. And then we have basically a soup of neutral gas, and then the first stars start forming. And the first galaxies start forming. And they start evolving, until what you see, we unfortunately can't see here, which is, in this bit, you have a cluster of galaxies, and one of them is just a galaxy, and in just a bit of the galaxy, you have a solar system. So the universe is massive, and you have all these things out there. And with the SKA, unfortunately, when the first stars were born, we call that the epoch of reionization, because these first stars are going to produce a lot of energy, and they're going to ionize all the gas around it. And to understand this better, we'll know the formation of galaxies, and this is very important to understand the history of the universe. But the other thing, and this is what I like a lot, is something that you can't see, unfortunately. colors are not very good, is later on, when galaxies are formed, the way these galaxies are distributed in the sky tell you their evolution. They give you information about their evolution, about the origins of the own universe. So how galaxies are distributed here is going to tell you what happened here. So that's what I'm really interested about, and but it's a very complicated math, beautiful math, but you know, how things are today is related to how things are in the beginning. And the SKA is going to help us, for the first time, understanding how things are organized in the most further away distances. Isn't that going to be so cool to know the history of the universe? You know, we're not actually, we're not astronomers. We're archaeologists of the universe. So, but there's other things, and one thing is pulsars. I don't know if you know what the pulsar is. A pulsar is a remnant of a star. So stars have a lifetime. They are born, they grow up, they leave, and they die. And when they die, one of the things that can stay is a pulsar. And a pulsar is something that pulsates. So when you look at them in the sky, they pulsate. They rotate, and they send a pulse. And this pulse is so precise that you can actually measure time with it. You can count time with it. Okay, it's the most precise clock you have in the sky. So here, when you have loads of pulsars, you can measure so well time that you can measure the ripples on the space-time. Okay, so space and time are kind of bound together, and so by gravity. So any sort of perturbation, it's like when you look into a pond, and any sort of when you drop a stone, any sort of wiggle there, these pulsars are going to help us to measure those wiggles in space-time. And by doing so, I don't know if you know who that man was, Albert Einstein. So we will know if he was completely right or not. So you see that something that's is being built in South Africa is going to answer the most fundamental questions in science and physics. Okay, isn't that amazing? Yeah, it's around the corner, like maybe 500. Oh yeah, it's going to tell. But there's also other things out there. When I told you there was planets, there's organic matter. You know, here I have some methane, here I have some sugar, and here I have some C2H5O, which maybe I shouldn't say what it is. Exactly. So organic compounds also emit light. So when things rotate, oscillate, these molecules, they emit light in the radio. And if we point to a planet, we would be able to measure if they have organic matter or not. So if they have any sort of organic compound. And these are the starting points of life. So all of us were made of you know, the simple things like things that are based on carbon and hydrogen and oxygen and nitrogen. Okay? And these complex molecules, proteins, sugars, carbs, they can emit radio. Then we can get the signal, radio signal from it. Okay, this is just a baby, but this instrument is so sensitive that you can look for organic matter, you can test gravity, and you can learn about the history and the beginning of the universe. And I'm just going to leave you with this. I'm going to show a video, but these are our fundamental questions. It's like, so where were the first stars? How were the first stars and black holes formed? And how did galaxies were formed? And what is dark energy? So dark energy is a form of energy that we will be able to understand better by knowing the distribution of galaxies. Is Einstein right? And are we alone? Are we alone? We don't know. We don't know any of this.